Okay, so in this video we're going to talk about what's called the quadratic formula. So in our quest to solve quadratic equations, we have used factoring, we've used solving by completing the square, we've used the square root method, and it turns out that if you solve by completing the square generally, you can get what's called the quadratic formula. Now the important thing about the quadratic formula is that it can be used to solve any quadratic equation when the equation's been written in standard form. And remember what we mean by a quadratic equation in standard form. It's this. It's let's rewrite that. It's ax squared plus bx plus c is equal to 0. Okay? That's what we mean by standard form for a quadratic equation. Now, just as a historical note, notice this is a polynomial equation where the polynomial is of degree 2. So if you think about second degree equations, the quadratic formula that I'm going to present in a moment was written down in its most general form about 500 years ago. So the formula I'm going to present to you, somebody wrote that down most generally about 500 years ago. And if this was third degree, right, that if you consider not a quadratic equation but a cubic equation, there's a formula for that as well. And that was discovered about 450 years ago. Okay, and you might ask yourself, what about a fourth degree? And the answer is, well, yeah, just kind of about the same time. So also about 450 years ago, somebody wrote down a general formula for a fourth degree polynomial equation. And then you say, okay, what about a fifth degree? And actually, there is no such equation. So what that means is that not just for fifth degree, but whenever the exponent gets to be a 5 or higher, there's no such equation that somebody can write down that'll give you the general solutions to that equation. That was shown about 200 years ago. That's kind of a miracle. Think about that. Somebody, up for the first few examples, they showed that such an equation does exist, right? Up to fourth degree. But for fifth degree and higher, somebody showed that something doesn't exist. That's much more difficult, right? To show the non-existence of something. And that's a really interesting story, and mathematically really a really beautiful, it's really elegant, the theory that addresses that issue. So the quest to find a general formula has been one that sort of spanned the ages. And the quadratic formula, that is for a quadratic equation, here's the formula that gives you the solutions. It's this. It's x is equal to negative b plus or minus the square root of b squared minus 4ac, and then all over, you have to divide that whole thing by 2 times a. Okay? This is called the quadratic formula. Okay, let's give that a box. So this formula, the quadratic formula, like I was saying, was discovered, written down generally about 500 years ago. Okay, let's go ahead and see how that helps us to solve any quadratic equation. Let's take some examples. Let's solve 2x times x minus 2 is equal to 3. So the first thing we want to do is write this in standard form. Ax squared plus bx plus c is equal to 0. So I'm going to take this 2x and I'm going to distribute. So 2x times x is 2x squared, and then 2x times negative 2 is negative 4x, and then it is equal to positive 3. So we want 0 on the right-hand side, so it's going to be 2x squared minus 4x minus 3 is equal to 0. Okay, at this stage, you want to identify your a, your b, and your c, because the formula references those values, right? So let's write that down. A is equal to, well, for this problem, a is 2, b is actually negative 4, and c is negative 3. Okay, now the quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac, and then all over 2a. So what we're going to do is we're going to plug in our values of a, b, and c into this formula. So we've got, let's see, negative b. Well, b is negative, right? So it's negative negative 4, and that makes it positive 4. Do you see that? It's the negative of b, but b is negative. So the negative of a negative is positive 4. So plus or minus the square root of b squared, that's going to be 16, minus 4. And I like to multiply a and c together. And when I do that, a times c is negative 6. I'm going to put that in parentheses because I'm going to multiply that by the 4 that's there in a minute. Okay, all over 2 times a, which is 4. So it's going to be x is equal to 4 plus or minus the square root of, well, it's going to be 16 plus 24. I multiplied negative 4 times negative 6, and then all over 4. So let's finish this up here now. So I've got x is equal to 4 plus or minus the square root of, well, 40 over 4. Okay, now the square root of 40 can be simplified. So it's going to be x equals 4 plus or minus the square root of 4 times 10 all over 4. So x is equal to 4 plus or minus, and the square root of 4 is 2. So 2 root 10 over 4. Now remember, you can't just cancel these right away. And the reason is because it's addition right here, addition or subtraction. You have to factor before you can cancel. So I'm going to factor a 2 out of both of these. So it's going to be x is equal to 2 times 2 plus or minus the square root of 10 over 4. And then finally I can cancel. So this 2 cancels with a factor of 2 there. And my answers are 2 plus or minus the square root of 10 over 2. I have two answers, right? 2 plus root 10 over 2 and 2 minus root 10 over 2. Okay, so let's go ahead and take another example using the quadratic formula. Let's solve x squared plus 2x plus 3 is equal to 0. And again, identify your a, b, and your c. So a is equal to 1, b is equal to 2, and c is equal to 3. So the quadratic formula says x is equal to, okay, negative b, so it's negative 2, plus or minus the square root of b squared, which is 4, minus 4, and a times c is going to be positive 3, right? A is 1, c is 3, a times c is 3. Okay, then all over 2 times a, which is just 2. So x is equal to, let's see, it's going to be negative 2 plus or minus the square root of, okay, 4 minus 12 under the radical, all over 2. So x is equal to negative 2 plus or minus the square root of negative 8 over 2. So x is equal to negative 2 plus or minus, now the square root of a negative, that's going to be I, right, our buddy, square root of 8 all over 2. Now the square root of 8 can be simplified, so let's finish it up here. So x is equal to negative 2 plus or minus I times the square root of 4 times 2 all over 2. So x is equal to negative 2 plus or minus, and the square root of 4 is 2. So it's 2I root 2, again, all over 2. Now you have to factor so you can cancel. So it's going to be 2 times negative 1 plus or minus I root 2 all over 2. I factored a 2 out of both of these, right? And the reason is because now I can cancel. The 2's cancel. So here are my solutions. Negative 1 plus or minus I square root of 2. So I have two solutions, right? Negative 1 plus I root 2 and negative 1 minus I root 2. So notice in these problems that I was simply asked to solve, okay? And I jumped right to the quadratic formula, but sometimes that's unnecessary. Sometimes you find that you don't quite need the quadratic formula. And let me give you an example of that. Let's solve 2x squared plus 5x minus 3 is equal to 0. Now I can use the quadratic formula if I want, but in this problem it's much easier to just factor. So this is going to be 2x times, let's see, x is equal to 0, right? So it's going to be this binomial multiplied by that binomial. and it's going to be a positive 3 and a negative 1. And so when I set these individually to 0, I get 2x minus 1 is 0, or x plus 3 is equal to 0. So this gives me 2x is equal to 1, so x is 1/2. It's one solution. Or x is equal to negative 3. So in this case, I solved the equation without needing the quadratic formula. And so you might ask yourself, well, how do I know if I need the quadratic formula or if I can just simply solve by factoring? And the answer is you always try to solve by factoring first. And if it takes you longer than a couple of minutes, then you move on to the quadratic formula. So generally, solving by factoring is faster, but you don't want to waste too much time on it. If you're having trouble factoring, go ahead and jump right to the quadratic formula. Okay, so we're going to see how to use or why solving quadratic equations is important when we graph quadratic functions. Until next time.